My name is Filip. I work as a CTO at Lesslie.se. We automate international B2B payments. We use PureScript with the Erlang backend. And yeah, basically, I want software to be better. This is why I do this. And today we're going to talk about error handling. So, error handling. I mean, who needs it? It's not like anything's going to go wrong, right? So we could start with just the assembly approach to error handling. We're just going to return a value. I mean, if the input's correct, the answer is going to be correct. But if your input is bad or there's a bug, we'll still return an answer. I think we can all tell that this is not the ideal approach to error handling. So most of us are not using this. It's super fast though. So one of the first approaches that were used was Sentinel error values. So you have a special value return, and that indicates an error. For example, in the A2I function, if you call it with a string input, it will give you an integer return value, or it will give you a 0 if anything goes wrong. So how do you tell if something goes wrong? If, like, is the input a 0, or did something go wrong? So it's quite obvious. You got to check the string yourself, right? If you get a possible error value back, you got to check it. So you look at your input, and it looks something like this. Like, we have a bunch of white space, we have a -0, and then ASDF 123J. This clearly is a 0, right? It parses as a 0, everything is fine. Also, this is also clearly a 0. Yeah, basically, like, we can do better than this. Another approach is Sentinel happy values. So you have a special value that tells you everything went right, and then you have lots of different values to tell you kind of what went wrong. So most programs have this. Like, you have int return values from basically anything you run in a shell. So just return 0 if everything is fine. The problem, though, is that it's really hard to tell what went wrong. It's like if you get error code, usually they're not really documented. You don't, like, if you were running a shell command from a shell from a programming language, it's kind of hard to know if this 97 is from, like, is this from Git or from Bash, or is it from the OS? Like, where is this 97 from? How do I even find that? And the return value is usually out of band. Like, you write to standard out, or you write to files on disk or something like that. Another popular approach is to use string return values. So you print a string to standard error, or if something goes wrong, and then you parse the string. Or rather, you show it to a human who looks at the string and decides what happened. So this is great for human readability. Like, you have a string, you can put anything you want in it. It's quite easy to include some context. You can include, for example, the path to a file which you failed to open. It is, however, completely horrible for computers to parse. A way to make it easier to parse these values for computers and still make them kind of readable for humans is to print these error constants. So, like, you have a predefined set of error values which are kind of human readable. And these are quite easy for computers to parse. But you can no longer include arbitrary data in your error message. So you can't tell anyone, like, what string constant you had an error with. This brings us to the next step. The obvious next step is just print a JSON blob or something similar to it. So you can still read this. It's easy for computers to parse. Like, we have lots of tools to do this. You can add any metadata you want because it's separate from the string. It's still easy to parse. Basically, these are like some historical common ways we have handled error messages. But there are so many more. And I'm pretty sure you have invented your own as well. Because we don't really talk that much about error handling. It's like you raise errors and you maybe catch errors, but yeah, we don't really talk about it that much. And the biggest problem about this is that everyone uses their own system. So there's no standard for this. And if every developer, every software project, and so on uses their own standard, I mean, what does 97 mean? How do I even handle that? Like, where do I even start? So sadly, there's no way we're going to reach a global consensus on this. We have software already, like that's not going to change. But we could have local consensus. Within our own systems, we could have one error handling system and stick to it. So here is how we're going to do it. I'm going to try to convince you that you should do this. Step 1, we're going to change hat. You are not the one raising the errors, you're the one catching the errors. And if you start from that perspective, it's way easier to figure out what metadata you need to include and how to make it easy to handle, easy to parse the error messages. So think of this from the user perspective. I'll give you one example of an error message. What happened? Well, we have some error when we are handling user permission error. So probably an error handler got an error and we're handling a new error inside that error or something like that. Sorry, there's actually a comma here. Someone forgot to add a comma. So we have a completely different error. This is basically SQL injection. Like, it's hard to tell what part is data and where the limits between different fields are. So if you just use like printf or something like that to print your errors, these are the issues you end up with. But what you could do is use something that kind of looks like JSON. I mean, you use whatever language you want. You have something that looks like this in pretty much all languages. It's a struct or whatever. And this way it's perfectly clear that there's a boundary between these two strings. So I am going to claim that all errors are eventually parsed by computers and only occasionally read by humans. And we should write our error handling with this in mind. So another error. Here's the scenario. You checked out a Git branch. You just run the test suite. I mean, you make test or whatever, and you got some kind of file not found error. What happened? Where do we even start with this? Like, there's not nearly enough information to even figure out what's happening here. It's like, what file was it? Is it a build config file, preventing our build tools from even starting? Which build tool, if we're using multiple ones? Is there a runtime config file preventing the app from starting, but we finished building it? Is it just like a bad git merge, so we have renamed the file, but an import was on a different branch or something, and now it's like pointing to a file which doesn't exist anymore, or which has been renamed? I mean, the solution to this is to be more specific. Like, file not found is not informative enough. So we could do something like this. And this might feel a bit verbose, but I mean, it tells us what happened. So I'm going to encourage you to rename your errors, catch errors, and raise them again with more information and a better name. We're going to do one more example. HTTP status code. You're talking to a REST API. You got a 403 permission error. What happened? Sorry, it's I'm not even. I don't even know how to solve this. Like it's just a lost cause. It could be from any place, like load balancers or whatever. So please, be specific. Okay, what about this? This is specific, right? I mean, it barely fits on a slide. So, are we there yet? Is this what we're looking for? Someone saw that we're only halfway through the time slot. Well, basically, we still want to figure out what happened. Like, which user? What file? There's still follow-up questions to something like this, and you need more metadata for this to actually figure out what happened and to be able to handle this in a proper way. So, since errors should be caught, we should try to make them trivial to handle. And one important part about that is the metadata. And you might be asking, like, what kind of metadata? What do you want me to include? And I mean, basically, I want all of it. Like, I want to know what happened. I want to know if the error is a temporary error, like is it going to fix itself if I retry later? Do you want me to retry? I want to know some timestamps and timings. Like, if I'm actually going to dig into this, I want to know like what part took a long time. I want to know how severe this is. Like, if this happens and it's like not caught anywhere and it just ends up in a default error handler, should we wake someone up? Like, if this is on a Saturday night, should we wait until Monday morning, or should I wake someone up? And also, like, probability. Do we expect this error to ever happen? Is this like a normal thing? Like, I don't know, user pressed cancel in the UI, or is this something that definitely should not happen? Like, I don't know. We also want to know, like, who wrote this error? If I actually have to dig into this, who do I talk to? Where do I even begin digging? Like, if I don't understand this, who is the person I talk to who should improve this error? We're not done yet. Like, I want all of it. I want the UID of the error that's thrown. I want to be able to refer to this particular instance of this error being thrown so I can see it in the log files. I want to see any API keys related to this. I want to see the X request IDs if you're doing any HTTP requests. I want some kind of stack trace. Like, sure, you can use the normal stack trace to actually look at a stack, but you could also look at the like the path you took through the application to get here. And also, if you have this much sensitive information, we probably need some kind of access rights to this. Like, is it safe to log the API keys? Should we show the API keys to the user? I mean, you got to decide that. And I mean, in the limits, I want the entire environment. Like, I want the breakpoint here. I want to be able to jump in and continue from where I was, fix some code, you do it like a hot reload, and continue from there and see if I fix the problem. This is a lot of information. And we could just summarize it as like, I want all of it. I want all of the metadata. But I rarely get this. So I'm going to encourage you to keep the metadata. Just keep it around. It's trivial to throw away later if you don't need it. But digging it back out of the log files or whatever, that's, yeah. I mean, sometimes it's not even possible. Also, I want each and every one of you to understand that this is not difficult. Like, you can do this today in basically any language you want. Like, we use quite advanced languages at Lesslie, but I mean, if you want to do this in any language, basically you can. So I'm going to give you a simple spec of basically what's required to do this, and you can think about your favorite language and how you would implement this. So first off, we need to be able to return a happy path value. Everything went right, here's the value, return value. We want to be able to return any single error value. You can think of this as throwing an exception or returning like an error tuple in Elixir or what have you. We want to be able to catch any single error label and leave everything else for upstream to handle. And we want the errors to be absolutely trivial for the error handlers to parse. So this is basically what you get in any language, if you think about it. This is not hard stuff. I'm going to recommend some more points. You can get these by having like a sufficiently smart compiler, or you could use static analysis or unit tests, or just don't make mistakes. Like I don't really care how you do this, but I recommend you have some tooling for this. First off, catch every error. Like all of them should be caught. If you have, like if you're throwing an error where you don't have a handler, that should be an error, preferably at compile time. And also, you should never have to handle errors, which can never happen. So if you're adding two numbers together, you should not have to handle the GitHub token is out of date error. So you can do this today in any language, basically. And I want you to. For example, C. Use a struct. This is just one suggested example. Use a struct. You have one global int tag telling you what the error is, and a void pointer to a specific struct depending on what the tag is. If you're using something with interfaces, you can use that instead of a void pointer, and you can case on the interface. If you have something that has support for some kind of algebraic data types, you can use that instead. If you use something with row types or variants, you can use that. It's quite powerful. We use v-except-t, for example, in PureScript. If you have classes, I mean, just have one error class and specific subclasses for each of them. Don't nest them, though. Have just a flat hierarchy of them. I don't know Rust, sorry. But you could probably do it. I couldn't find a quick way of doing it without unsafe, but you could probably figure out a way. And for Elixir, like you're almost there. You're so close. You have these error tuples. Instead of error, just make a longer name, and you're basically there. So I want to tell you that you can do this today. There's like zero barrier to entry to this. Also, you can do this with like a gradual introduction. You can pick a small corner, and I want you to pick a small corner of your code base and try this out to try to figure out how useful this actually is. Just a small, like 1 hour experiment, and you can probably figure this out. So you could use like a JSON parser or the parsing function for a single REST API call. Then I want you to take any error messages you get from upstream and convert them early into this, into your own error handle, this error format that you use internally. And I want you to catch all of these errors as quickly as possible, like right at the edge of your code base, and convert it over to these new, to your new error types. And then I want you at the other side of this experiment to rethrow these errors using the old errors handling system that you had before, so that the rest of the code base doesn't have to know about this. And then, if it's useful, the border, just move it. Pick a new space in your code base to do this experiment again, or use the same area and just move where the translation boundary is. So you can pause this at any point and continue rollout like 3 months later if you find it useful. Or just stop, like it's fine. I am also going to encourage you to be very explicit when you do this. Each of the error tags should be raised in exactly one place. And I don't want you to group the errors. I want you to handle them separately. It's fine to have like a just general something went wrong handler that you're running on 50 different errors. That's perfectly fine. But if you have 50 different error tags, then you can later decide that one of those 50 is something we actually need to handle in a better way. And then you can also be more specific over time. So if you're using an upstream REST API, I mean, the documentation for those usually doesn't line up with what's actually being returned. So if you have a default error handler that should never run, that just catches whatever response you got that you were unable to parse as a more specific thing, you now have a unit test and a new like evidence that this piece of information, this data format, can be returned from this endpoint. So it's a perfect thing, like perfect, exactly the information you need to write this new parser. So, to recap. Why do we even have error messages? I mean, the obvious answer is that we want to describe what went wrong, right? If something went wrong, you want a message. But I would argue that this is actually an XY problem. Nobody actually cares what went wrong. They want to fix it. Like if you get an error, you want to fix it. So error messages should lead you to the next action. When you throw an error, what do you want the error handling code to do? Do you want them to retry? Do you want them to like send the user to contact support? Like what do you want them to do? And related to this, most error messages, they describe the problem in the context of the person writing the code that is throwing the error, not the context of the user handling, like the user of the code handling this error. So for example, this is a perfectly fine error message, like just like you need metadata, of course, but like sure, this input file is in some weird character coding. We only support UTF-8. Like fine. This is something like I see every once in a while. You run a parser, and like at some position there's a bad character, and you couldn't parse it. Okay, great. I know what to do with the top one, like, but the bottom one, I don't know. I would also argue that the error handling is everywhere, like absolutely everywhere. It's not just the edges of binaries between different programs. It's not just the API endpoints. It's not just packet boundaries. It's like absolutely everywhere. So it's worth thinking about. So what should my code do about it? Every error message should come with a suggested next action. If I get an error, tell me what I should do with it. Is it a temporary error? Should I ask for help? Was it a bad input? Invalid input? Do you want him to back off and retry later? Because I want to tell a computer how to do it. We write code that calls other code. That's what we do. There's never really a point where there will always be a human interacting with a system. Like you're going to automate things. That's what we do. So all error messages are going to be parsed by computers eventually. And only occasionally are they read by humans. So standardized format is really important. And what could possibly go wrong? It's like edge cases, that happen all the time. And you need to know what could possibly go wrong. So if you have these like very explicit error tags, then you could just case on them and you can see exactly like these are the things that could possibly go wrong in this part of the code base. And you can handle all of them. Like it's basically just casing on the value. And you also want this feature of like what couldn't possibly go wrong. I don't want to handle an error that is completely unrelated to the thing that I'm actually coding. So like make sure that you don't have to handle the errors that will never happen. So we're going to trace what errors are possibly reachable to the point where we are. And I want it to fail early. I don't want to know that undefined is not a function. Like I want just let it crash. You don't want to clean up your own mess. This is like Erlang stuff. Because if something unexpected happens, it's unexpected. Like this untested code path, you don't know what to do. Just crash and let upstream handle it. And also sprinkle assertions everywhere. Like if you think that something could possibly go wrong, or you make an assumption somewhere, write some code that crashes if it doesn't match. And keep the metadata around. Erlang, why are you truncating my strings? Like I have so many times I've seen this in the log files. Like, yeah, here's a big bunch of text, and then just before the stack trace and the actual array information I need is truncated because like the string is too long. And the same thing here. Like you have a tag, but there's no metadata here. I want the metadata. I need to know like what user, what payment, what happened. And it's basically impossible to reconstruct this data later if you threw it away. Like it's just keep it around. And you usually don't know what you wanted to see until something is actually on fire. Like when you actually see that crash, that's when you know what the data you want to see. You don't know that until that point. So the only real documentation is code. And throwing away metadata is a premature optimization. So normalize the errors. Turn them into your own format. Actively add more errors as you learn. Whenever you see something weird, add a new error, add a new assertion, new error. Just have as many errors as you can possibly think of, basically. Just handle them explicitly. And unit tests. Test all your errors. And this will lead you, like if you're interacting with a REST API, you're going to know the API better than the authors of the API quite quickly, because you have seen the edge cases. You have so much more data on this than they do. And also benefits, like if the person who wrote this quits or changes teams or just forgets about this code because nobody's touched it in a year, the code still remembers. So error handling and error messages are incredibly important. They're a solid foundation to stand on. Knowing exactly what could possibly go wrong allows you to write code much more quickly. And it might seem like a lot of work, but this really pays back over time. There's a lot in here. I am going to encourage you to watch this presentation again, because I want you to implement this yourself. And this is meant to be a guide that you can follow to implement this in your own language. And you now have more context, so watching it again is going to be a different experience. Thank you. Questions? Because okay, why shouldn't error types be nested? Because when you nest error types, you are going to handle them as a group. And it's much easier, like less friction, if you have used the same handling function in 50 places to like replace one of them, rather than having one place that you're handling the errors, and it's a group of 50 errors. Also, it's quite common when you group things that you throw away the information of which actual error it was.
So you said quite late on in the talk, the sort of Joe Armstrong advice from Erlang, let it fail. And that seems to be in conflict with what you were saying earlier on about handling all sorts of errors. So and that made me think there's not one approach here. You've got to decide how far to let your errors percolate before, maybe handle them for a bit and then fail, or you fail immediately. Because failure in Erlang means that you then go into supervision, and there's only a few things you can do within the supervision model. So how do you make choices between where to handle and where not to handle, or when to fail and when not to fail?
Yeah, so one good separation here is that you're either doing logic or you're doing orchestration, i.e. error handling. So the error handling in Erlang is usually supervision trees, but you don't have to use that. We use PureScript, so we have quite strict types. So what I actually mean is, if something goes wrong, don't try to handle the error locally. Return it upstream and let them handle it. And that might be supervision trees, or it might be like an error handling function one step higher up.
Okay. So you have to make a decision about how far you push things up, or just, and there comes a point where you can't handle it, so you fail.
Pretty much, yeah. And then you just log and crash, restart, whatever.
Okay, yeah, that's helpful. Thank you.
When you talked about the information that we should provide with the error, you talked about not just a stack trace, but a path, the path the program took to get there. I can't tell the difference. What can you give an example of the difference?
Yeah, if you have, just think of two stacks. You have one which is just the return addresses, so that's a call stack. But you quite often want to like add more information into that kind of stack. It would be nice to have like a call stack, but you can also add in like, the user logged in, or we're this user, like in the context of being this user right now. And that is basically what I'm talking about. So you separate those two, and you have the application stack of like, I am currently, whatever, running this background job that's running because someone is telling me to update something by clicking in the UI.
The application-specific things.
Yeah. And you can have more information there than just the return values, or the return addresses.
So one thing that would be interesting in terms of, this is mostly a suggestion, and then you can say if you think this kind of makes sense or not, right? If we want sort of the stack trace and so on, it's also interesting in a system that maybe has many actors in it and so on, and messages between those actors to kind of save, in some sense, the event stream that has led to our current predicament, right? Do you think that would be a useful kind of thing to do and generalize around?
Yeah, like storing the path of the messages, as in like, I am running because of this, and that was running because of this. That is basically this application stack. Not the call stack, but the application stack. I'm not sure if that answered your question.
Right, sort of, right? But if we're, for example, we're having issues in a process, we might say, for example, here are the messages I received that led to this. In that case, we can actually kind of discard everyone else because we're concerned with this process. So we can test that process with that event stream actually outside of time, basically, and just replay the entire event stream, fold over it, basically, right? Or we can save an index into an already existing event stream that's saved somewhere, perhaps, right? I was wondering what you thought about maybe that kind of isolated model of looking at this.
Sure, go for it. I mean, Erlang already has this. Like if you crash on a message handler, you get the last message in the crash message. So just add 10 more or whatever you need.
The entire thing, all of it. I want all of it, right?
Sure. I mean, until you've proven that you don't have enough memory or whatever to actually have all of it, I want to have all of it.